2011 connected particles question. A smooth pulley of mass 2 kilograms is connected by a light inextensible string passing over a smooth light fixed pulley to a smooth pulley of mass 5. Two particles of mass 1 and 3 are connected to the 2 kilogram and two particles of mass 4 and 6 are connected by a light inextensible string over the 5 kilogram. Find the tension in each string when the system is released from rest. Okay, so there's a lot going on here. Let's put our T's in first. T1. T1. We have T2. T2. T3. T3. And we put our accelerations in. The 5's going down, so my A from the top is this one. 2's going up, so the acceleration of the 2 is this one. Now, if we apply an acceleration of B to the 1 and the 3, you can see that the 1 is going to go up and the 3 is going to go down. So the acceleration of the 1 is going to be the A and the B. And the acceleration of the 3 is going to be the direction that's going B. I'm taking away the acceleration going up. So that's the acceleration of the 3. The acceleration of the 4, well, let's do the 6 first. The 6 is going down with acceleration of A and we'll call this one C. So the 6 is A plus C going down, which would mean that the 4, if I do it over here, the 4 is going to have an acceleration. It's going down with C and up with A, so C minus A. So let's try and fill out some equations for these. There's a lot involved here. So if we go left to right, we're going to say with the 1 we have T2, we have G going down, and we have the acceleration up of A plus B. So the equation for 1 is going to be T2 minus G is equal to 1 times A plus B, or just A plus B. The key in this question is to eliminate accelerations B and C to just get the acceleration of A, and if we can get the acceleration of A, then we can get the tension in each string. So the 3 kilogram mass has 3G going down, T2 going up, and it has the acceleration that we said going down of B minus A. So this equation is going to be 3G minus T2 is equal to 3 times B minus A. So if we do that now, we eliminate B from these equations, we're going to get 3G minus T2 is equal to 3B minus 3A. So if I bring the top one down and multiply by minus 3, I'm going to get minus 3T2 plus 3G, that's the left hand side, multiplied by minus 3 is equal to minus 3B minus 3A. So I'm going to get 6G minus 4T2 is equal to minus 6A. And dividing by 2, I'm going to get 3G minus 2T2 is equal to minus 3A. So if I do something similar with the 4 and the 6, do it here, let's have a look at the 4. 4G, T3 going this way, and we're going to try and eliminate C from these equations. We know the 4 is coming, no, the 4 is going up. I had it coming down here, it's going up. It's definitely going up. 4 is going up with an acceleration of C minus A. So we can say that T3 minus 4G is equal to 4 times C minus A. T3 minus 4G is equal to 4C minus 4A. Let's have a look at the 6. The 6 is going down, and we've got the two accelerations, the A and the C. We have T going up. We have 6G coming down. So we can say that 6G minus T is equal to 6 times a plus c, or 6a plus 6c. We want to get rid of c, so we're going to multiply this one by, well, at no point I can't, yeah, I think 24 is the best way to get it up to. If we multiply this one by 6, we're going to get 6t3 minus 24g is equal to 24c minus 24a. So then we multiply this one by minus 4, we're going to get minus 24g plus 4t is equal to minus 24a minus 24c. So let's bring them together. And we're going to get minus 24g. I've left out a number here. I've left out my 3. Minus 24g plus 6t3 is equal to minus 24a plus 24c. So I have minus 48g plus 10t3 is equal to minus 48a. And if I divide that by 2, or minus 2 to tidy it up, I'm going to get 24g minus 5t3 is equal to 24a. So now I can get t2 and t3 in terms of g and a. So 2t2 is equal to 3g plus 3a. And this one I'm going to get 5t3 is equal to 24g minus 24a. You can see why we're doing this. We're going to need, when we use the equations for the 2 and the 5, which we will now, we're going to have a t2 and a t3 and a t1. So if I can replace t2 and t3 with something that doesn't have t1 in it, we'll be able to simplify these equations down a bit quicker. So let's have a look at the 5 and the 2. We don't have room. We could do it over to the left here. Okay, let's look at the 2. T1 going up, and the T2 is coming down. So we have 2g, and it's going up with an acceleration of a. So we're going to have t1 minus 2t2 minus 2g is equal to 2a. And for the 5, we have my t3s here. I have my t1 here. The direction it's going is down with an acceleration of a. And we have our 5g. So the forces are 5g plus 2t3 minus t1 is equal to 5a. And now I can combine these two equations and get rid of t1, and then I can replace t2 and t3 with the equations that we have already got. So I have a plus t1 from this one here. I have a minus 2t2 minus 2g, and I have a 2a. So I'm going to get 3g plus 2t3 minus 2t2 is equal to 7a. And now I have these in terms of g and a. Excellent. So now I can definitely get a. So let's just bring them across here. We can see them all together. So we want 2t3. Well, I've got 5 of them here. And we want 2t2. So t3, let's just simplify that. It's going to be, if I divide by 5, 24g minus, should be 24g minus 24a over 5. So I can put that in and multiply it by 2. And I have, I'm looking for minus 2t2. So let's just get minus 2t2 minus 3g minus 3a. And then sub them in over here on the left. So I'm going to get 3g plus twice t3, which is 24g minus 24a over 5. minus 2t2, which is minus 3g minus 3a, and that's all equal to 7a. So now we can solve for a. 3g plus 48g over 5 minus 48a over 5 minus 3g minus 3a is equal to 7a. So bring my a's across. I'm bringing this one and this one over. So I'm going to get 3g plus 48g over 5 minus 3g, I should have cancelled them, I didn't see that, minus 3g is equal to, just double check I'm including everything, I've got my g, yes, 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 I'm bringing across 7a, I'm bringing across 3a, and 48a over 5. So I'm left with 48g over 5 is equal to 10a plus 48a over 5. Well, I might maybe just multiply by 5 to simplify this. 48g is equal to 50a plus 48a. So 98a is equal to 48g. So a is equal to 48g over 98. Well, that's 9.8 on top and the 98 in the bottom, so that would leave a just being 48 divided by 10, which will be 4.8 ms to the minus 1, and this will enable me to get all my tensions. So quite a long question, and a lot of simplification involved, a lot of different equations, a lot of unknowns. It's a question that needs to be practiced. This could come up in 2020 or 2021, so get practice on this question. So T3 is here. Let's get this first. T3 is equal to 24 by 9.8 minus 24 by 4.8 divided by 5. So the calculator use, T3 is equal to exactly 24 newtons. Where's my T2? It was up here, wasn't it? T2 is equal to, well, they were all positive. T2, just to go a bit, is equal to 3g plus 3a over 2. 3g plus 3a over 2. So T2 is equal to 3 by 9.8 plus 3 by 4.8 divided by 2. So typing that into a calculator, comes out as 21.9 newtons. And then T1, where's my T1? Let's find the easiest equation for it is up here, is it? T1 is equal to 2T2 minus 2G. T1 is equal to 2A plus 2G plus 2T2. T1 is equal to 2G plus 2A plus 2T, what was it, T2? 2T2. So T1 is equal to 2 by 9.8 plus 2 by 4.8 plus 2 by 21.9. And if we type that into our calculator, we're going to get T1 is equal to exactly 73 newtons. So be prepared. 2020, this question's coming up.